Hello friends, welcome back to my channel. In today's session, we will learn about Einstein's coefficients. So let's start Einstein's coefficients. Suppose friends, we have atomic systems and which has this is two energy levels, and suppose energy of lower energy level is E1 and energy of higher energy level is E2. And again let so, in it initially there is n1 atom is lower energy level and n2 atom is in higher energy state E2. And then between these two energy levels there are three types of transitions of atoms are possible. First one is absorption transition, and the second one is spontaneous transition, and the third one is stimulated transition. Now let us see these three types of absorption one by one. So let us see first about absorption transition. First one is absorption transition. So what is absorption transition? Friends, we have already described about absorption, spontaneous and stimulated emission or transition in our previous video. If you have not seen, then please see that video, then you can easily understand about absorption and spontaneous and stimulated transitions. So let us see here about absorption transition. Here we will see the probability of absorption transition is depends on what. So we can easily know that if this atomic system is suppose placed in the radiation field of energy density E nu, then what happened? This absorption transition probability will be depends on the number of atom in ground state and in energy density. That means we can say that if P12 is the probability of absorption transition, then it will be proportional to number of atom in ground state, and also P12 is proportional to density of energy, energy density. And here we can write as P12 is proportional to N1 and into E nu. Here when we replace a proportionality sign, then we will take here one proportionality constant. Suppose proportionality constant is written as B12, then P12 will be equal to B12 N1 and E nu, N1 E nu. Here B12 is the proportionality constant. Here B12 is the proportionality constant, and it represents absorption probability per unit time per unit energy density. Suppose this is the equation number 1. Now let us see second transition, which one is spontaneous transition. Here the probability of spontaneous transition is proportional to number of atoms in excited state. Hence, if P21 is the probability of spontaneous transition, then it will be proportional to N2. And when we replace the proportionality constant in here, again we will take another proportionality constant, and here A21 is the proportionality constant, and A21 represents spontaneous transition probability per unit time. Suppose this is the equation number 2. Now let us see about third transition. And the third transition is what? Stimulated transition. And the probability of stimulated transition is proportional to the number of atoms in excited state and it is also proportional to the energy density. Hence, if P21 prime represents the probability of stimulated transition, then it will be proportional to N2 into E nu. When we replace here proportionality sign, then here we again take one proportionality constant B21, then P21 prime will be equal to B21 N2 E nu. Suppose this is the equation number 3. Here B21 represents the induced or stimulated emission probability per unit time per unit energy density. When system, that means atomic system, is in thermal equilibrium, then total number of absorption will be equal to total number of emissions. That means here we can write as P12 will be equal to P21 plus P21 prime. Here P12 is the probability of absorption transition and P21 is the probability of spontaneous transitions and P21 prime is the probability of stimulated transitions. Let us put the value of P12 and P21 and P21 prime from equation number 1, 2 and 3 respectively. Then we get what? B12 N1 E nu is equal to A21 N2 plus B21 prime N2 E nu. ये हम देख पा रहे हैं कि ये वाला टर्म में ई न्यू है और इस टर्म में ई न्यू है. देन हियर व्हेन वी सॉल्व दिस इक्वेशन फॉर ई न्यू, देन वी गेट ई न्यू इज इक्वल टू A21 N2 upon B12 N1 minus B21 N2, and again by solving it we will get, now we will divide numerator and denominator by these terms B21 and B21 into N2. Then we will get what? A21 by B21 upon B12 upon B21 into N1 by N2 minus 1, and this is the value of E nu. Suppose this is the equation number 4. But according to Boltzmann distribution law, the atomic population at any energy level at a given temperature T is given by the relation N2 is equal to N1 exponential minus E2 minus E1 by KBT. Here KBT is the Boltzmann constant, and N1 exponential minus here E2 minus E1. This is the energy difference between the two energy levels of the atomic system, and it will be equal to h nu. Therefore, we can write N2 is equal to N1 exponential minus h nu by KBT, and from here we can find N1 by N2 is equal to exponential h nu by kBt. Suppose this is the equation number 5, and here we will put the value of n1 by n2 from this equation in equation number 4 here. Then we get what? The value of E nu will be equal to A21 by B21 upon B12 upon B21 exponential h nu by kBt minus 1. Suppose this is the equation number 6. And friends, as we have already known, according to Planck's radiations formula, the energy density, the value of energy density. So, but according to Planck's radiation formula, the energy density of radiation at a given temperature is E nu is equal to 8 pi h nu cube by c cube into 1 upon exponential h nu by kBt minus 1. And suppose this is the equation number 7. Friends, when we compare equation 6 and 7, we get A21 upon B21. That means we can see here that value of A21 B21 will be equal to this s pi h 8 pi h nu cube upon c cube, and the value of B12 upon B21 will be equal to 1. Hence, A21 upon B21 is equal to 8 pi h nu cube upon c cube, and B12 upon B21 is equal to 1. That means here we can see that B12 is equal to B21. That means proportionality constant in spontaneous and stimulated transitions is equal. And since these two relations is first obtained by Einstein, therefore here A21, B12 and B21 is called Einstein coefficients. Now from equation 6, this is equation 6, we can write it as A21 upon B21 E nu is equal to exponential h nu by kBt minus 1. Hence, we can write it as spontaneous emission probability upon induced emission probability. अर्थात ये A21 represents spontaneous emission probability and B21 E nu represents induced emission probability. That means this spontaneous emission probability is equal to B21 E nu is equal to exponential h nu by kBt minus 1. Now, when we see this equation, then if h nu is greater than kBt, then we can say that spontaneous emission is much probable than induced emission. Then spontaneous emission or transition is much probable than induced transition. But when h nu is less than kBt, then induced emission is much probable than spontaneous transition. ओके फ्रेंड्स, तो आज की क्लास से बस इतना ही. नेक्स्ट विल सी इन आवर नेक्स्ट क्लास.